Okay, so now to go over the homework for the table, the first thing I would highly recommend that you do is to print out the Z table. That is going to be something that you use for the rest of this unit as well as other units, and it is very, very important to be able to have a hard copy of this. Doing that digitally would be pretty difficult. So I highly recommend that if you have a printer or printer capability, that instead of having to go back and forth between the screens, you actually print out that value. Now, with that being said, I'm going to go through the problems that they have here. So in number 11, the first problem that you have is it says if you have a normal distribution with a mean of 12 and a standard deviation of 3, find the following probabilities. So before I do anything, you'll see the very first thing that I have is I've drawn the picture. I draw the normal distribution. I put that mean of 12 right in the middle. And now I know that 10 is less than 12. So I know it's going to be down here somewhere, okay? 10 is less than 12. It's not quite a full standard deviation away. I can see that even before I do the math. Before I do the math, if it was a full standard deviation away, I would actually have it at 13 because I'd be, I'm sorry, at 9 because I would subtract 12 minus 3 would be 9. So I know it's less than a standard deviation away. That's my thought process on this first one. In this one, they want to know what's the probability that I have a score greater than 10, bigger than 10. So the next step was shading. Step 1, draw it. Step 2, shading. I'm shading to the right. And now I calculate my z-score. That's step 3. Step 3, I calculate the z-score, so I take 10 minus 12. It's a negative. I expect that. I see that in the picture. It's below the mean. So negative 2 divided by 3 gives me negative 0.67. Negative 0.67. So what I'm going to do next is I'm going to go to the negative side of my z-score table. I'm going to look up negative 0.6, and then all the way over to 7, which is right there. It is 0.2514. That's the area to the left, 0.2514. So if I drop these last two off, which you guys are welcome to do, I actually round, and that still rounds to 0.25. It means that 25% of the values are to the left of that 10, which would mean that 75 should be to the right of it. The way that I'm doing the math behind that is when I'm finding the area to the right, I always have to do 1 minus the area that I got. 1 minus that 25%, which gives you about 75%. I use the full number here, but feel free to do, to make it a little easier on yourself, to round that to 2 so that you would get 75% right there. Okay, so 75% of the values are higher than 10. So now we go to the next problem. The next problem says, what about values less than 16? Values less than 16. So you're going to see me do this same process. I'm going to speed it up a little bit. But less than 16 would mean that I draw the picture. 16 is bigger than 12. And then I'm shading the area. Less than means to the left. I calculate the z-score. I get 1.33. So that's already more than a full standard deviation away. So I get 1.33 standard deviations. I go to my table. I look up 1.33 and I follow that down and I get 0.9082. 0.9082. That's about 91%. But again, I'm showing that arrow in every single one. That's the area to the left. That's what that table does for me. It tells me the area to the left. Well, I'm in luck. That's actually what they wanted. They wanted to know the area to the left. So 91. 0.91 is the probability, which means it's in the 91st percentile. That's how we would say that. It's in the 91st percentile. Moving on to C, we do the exact same process, except for this one is between two values. What percent of values are between 9 and 15 if the mean is 12? Well, I calculated the z-score for each one of those. So I first take the z-score of 9 minus 12, that's 3, divided by 3 is negative 1. That's 1 standard deviation in this direction. This one's 3 away in this direction. It actually gives you a z-score of 1 also. okay? If the standard deviation is 3, if I add 3, that's 1 standard deviation. If I add 3 more, that's 2 standard deviations. So this makes sense for it to be 1 and -1. So now I look up those values. That's the next step. So step 1 was to draw it. Step 2 was to color it. Step 3 was to calculate my z-scores, which I did. And step 4, I go to the table. So I go to the table. I'm going to look up 1 first. A z-score of 1 is 1.00. It's 0.8413. I go to the other side and I look up -1. A z-score of -1 is -1.00. It's 0.1587, so about 16%. You'll see I put both of those values there. I again put the arrows showing that that's to the left. In the last value, or in the last video, I explained that that means that 84% scored less than, it's this whole area, than 15. But I don't want the full area. I want to take out this little piece to get the area in between. So I can take this number and take out this little piece right here, which happens to be that 16%. So what I really have is 84 minus my 16%, which gives me about 68%. What it would mean in real life is that 68% of people scored right here. I'm going to relate this back really quick to the 68, 95, 99.7 rule that we talked about. We have that rule that says that if it's a normal distribution and the data is correct, then 68% of values should be within 1 standard deviation. That shows it right there. It shows it a different way using z-scores. Okay, I'm going to move on to number 12. Number 12 is a very important problem. Number 12 says that we have men's heights. They have a mean of 69 inches and a standard deviation of 2.5. And all you have to do for this problem is draw and label this z-score properly. So that's what I've done. I've drawn a big normal distribution. My mean always goes right in the middle, which happens to be 69 inches. And then we draw 3 standard deviations in either direction. So I have 3 standard deviations. That's why I show that there. And then I have 3 standard deviations going this way. So what I'm going to do to get where this value should be is I'm going to add 2.5. Then I add 2.5, then I add 2.5. I'm adding 1 standard deviation, now I'm adding 2, like adding another 2.5 and another 1. When I go the other way, I do that same thing. I subtract 2.5, then subtract another 2.5, then subtract another 2.5, and that builds my curve. It's really nice to see these because then it's easy when I say, okay, well, what percent of people scored less than 65%? Less than 65%. You have a point of reference. 65% is in between these two values, but kind of closer to here. It would show me that my z-score is going to be -1 point something. -1 point something, because it would be right in here somewhere. So these distributions really help us see where scores should be on here. Okay, I'm going to number 13 now. Number 13, we have IQ scores again. So we have a mean in this case of IQ scores of being 110 with a standard deviation of 25. What we're going to do here, it says what percentile is an IQ score of 150? Well, the first thing I'm going to do is draw my table. I draw this just like in every other problem that we've done so far. 110 is my mean. 150 is like way up here. So 150 is up here. I know it's more than 1 standard deviation away because if it was 1 standard deviation away, it'd be at 135. So I know it's bigger than that. So it's at 150 right here. What I do next after I shade, because I want to know at what percentile is it? Percentile, when I ask that question, that's at or below when we were doing percentiles. So that's actually the area to the left. Percentiles are what this actually shows you. So those are the areas to the left. So I have to then calculate the z-score. I get a z-score of 1.6, which means then I go to my table, my percentile table, and I look it up, and I look up on the positive side 1.60. 1.60, zeros up here, and I get 0.9452. 0.9542 is the area to the left, but I wanted the area to the left, so that's exactly what my area is. I'm in the 95th percentile if I have an IQ score of 150. Okay, last part of that problem. It says what percent of people have IQs between 125 and 150, right in this, right here, this area. So I did the same thing. I draw, I shade, and now I'm going to calculate the z-score. We already have the z-score for 150. I calculated it before, and I got that area was 95%. So now I just have to do the z-score for this one. 125 minus 110 divided by 25 is 0.6. It's not even a full standard deviation away. So that right there is a z-score of 0.6. I look up now in the table because I already looked up this to get 95, but I need to look up 0.6. So I go to the positive side. I look up 0.60, I get 0.7257, which is about 73%. And that's the area to the left. To get an area in between, I always take the higher number minus the lower one because this one is 95% all the way down, but I want to take out this piece right here, which happens to be that 73%. So when I take 95 minus 73, I get that 22% of people would have IQ scores between 125 and 150. Okay. The last problem is a bonus problem. We are going to get into this next module actually, and it's using the body to work backwards, but I figured I'd put it here to see if you guys could do it. If I scored in the 90th percentile, what that would mean is that I would be in the 90th percent on here, like the 90th percentile up here. Well, that would mean that my area would be the 90th percentile. So what I'm trying to do is figure out my z-score. What I can do is I can actually, I'm going to zoom in a little bit, go to the body of this and try to find an area that is closest to 90%. These are in the 90s, these are in the 80s. If I look carefully, 90% is between these two values. 90% is between 89.97% and 90.15. It's actually closer to this right here. That would mean that if I take that 90th percentile and I follow it back, it means my z-score was at 1.28. 1.28. So that's what I have here, is that would mean that if I followed it backwards, my z-score was at 1.28. So that was kind of the last, we haven't covered that yet, but it was like a bonus, hey, maybe you could get this problem. And that is all for homework from last night.